Welcome back, guys. Now, we are very happy to have our good friend Abhi here to talk about the black hole that was recently, well, not discovered, but we took a picture of it.
We took a picture of it specifically.
All of us. We as a species.
So, Abhi, why don't you tell us, I mean, I've seen a lot of stories. How did we take that picture?
The royal we.
The royal we. Oh, man,
so,
I get away with this.
M87,
Yes.
as the black hole is called, is huge. It can fit our entire solar system in it.
Yeah.
It's like
Show off.
It's like 40 billion kilometers wide.
Yeah, like something like just the black hole was like 6.5 billion times the size of our
You got
sun
it
or
right.
something like that.
You got it right.
Man.
Yeah.
That's a good.
Jeez, who's the astrophysicist here?
Insane. Not me. I just read an article.
His second Google search of the day.
And it's huge, but it's also super far away. It is 55 million light years away.
Oof.
Now, now talking about 55 million light years, how close is? What's the closest planet?
That's a ways.
That's a ways. That's a ways.
So light takes 8 minutes to get from the sun to Earth. So this takes 55 million years from the light from the outside of the black hole to get to us on planet Earth.
For light, so we're not getting there anytime soon.
Wow.
Which is
No,
good because there's a black hole there. So
They'll suck you in.
So,
Yeah.
so
Let's
if
try
we-
to avoid it.
So if we moved at light speed, it would still take that long.
It'll take 55 million years to get there.
Wow,
Right?
that's
So
incredible.
it's so far away that it's the equivalent of trying to look at an orange on the surface of the moon with your naked eye.
Okay.
That's where Neil Armstrong left his lunch, by the way.
Imagine you had a 180-degree view of the sky, right?
Yeah.
And you took like 1 degree of that. You divided that into 1,000 slices. You took one of those slices. You divided that into another 1,000. 42 of those little slices is how big the black hole is on the night sky. So it's so tiny that you can't see it. So the question is,
How do we know it's there?
how do we know it's there? We scientists have, that a little bit of the theory of the black holes is we used to think that gravity was an inherent property of objects. That like we think humans are inherently good. We thought every object.
Nobody thinks
No,
that
let
anymore.
Let down.
Not in submarine. But then Einstein came along and he gave us a new way of thinking about gravity. He said gravity is, if you think of space-time as a continuum, heavy objects bend space and time. So the heavier you are, the more space and time you bend. So black holes are so heavy that they bend space and time so much that even light can't escape from it. So we've theorized about black holes, we've known about black holes, we've observed them through just how they operate in the sky, but this is the first time we've been able to take a picture of it.
Right.
And we did that by turning our entire planet into a satellite.
I don't know how
Okay.
how's that
Cool
work.
is that?
How's that
How
work?
does that-
How's that work? Yeah.
I mean, isn't our planet already a satellite of the sun?
Nice.
See?
Well
Space
done.
humor.
Oh,
Yeah.
yeah.
So
you guys are so much smarter than me.
the larger the radius of a telescope,
Yeah.
the smaller an object and the more further an object you can see.
Okay.
So in the past, we had limited techniques of picturing things, so we would build bigger and bigger and bigger disks until we ran out of space, right? And so you can't build bigger than a certain size because it gets too heavy and so on. When people worked out the math on what it needs to get an image of this black hole, we needed a satellite the size of the Earth. So what scientists did was they developed a new technique. It's called very long baseline array. So essentially what you do is you can take images from different telescopes, and if you knew exactly when you took those images, it's effectively like having one giant telescope whose diameter is the distance between your two furthest away telescopes, right?
Wow.
So what we've done is we've taken a telescope, a network of 6 or 7 telescopes from Chile to the Pacific Ocean to Europe. And we've taken images at such a close resolution that these clocks that they use, hydrogen clocks, they lose a second every 1,000 years, so that's how accurate they are. So we've taken these images. It took 2 years to find a good window of time to look into space. And the amount of data that we collected was like 5,000 years worth of MP3 files is how much data we had to collect.
That's how much I downloaded in the early 2000s.
Wow,
by the
yeah,
way.
music, by the way, not other things.
2 years of number crunching.
Wow.
You put all this together, you get humanity's first ever image of a
Right.
black hole.
So we took this picture 2 years ago.
It took 2 years to roughly to compile to put the data together. yeah.
Wow.
And it's of a 55-million-year-old black hole, right?
So it's
Wow.
looking back in time.
That's super cool.
Yeah.
So this black hole may look differently in actuality now than in the picture that we took.
It may not be there.
But what is time?
That's a man-made construct, isn't
That's
it?
getting a little
I don't
too
know.
deep. I don't know.
Well, I think when we're talking about time, it's fair to ask that in
Yeah.
some sense of a black hole.
For sure, for
Because does it warp time like it does gravity?
It does. So what Einstein's theories suggest, a new framework of thinking about this, is space and time are not independent of each other, but they're one continuum called space-time. So just think of a trampoline, and imagine dropping like a bowling ball on it. You know how it bends? Now imagine dropping like a 55 billion, ton bowling ball on it. Imagine how much deep it would bend, right? So time and space, we don't know what it means, what space and time mean inside what we call the accretion disk of the black hole.
Right.
And so time and space beyond that event horizon, physics as we know it breaks down.
Okay. So what does this black hole mean for us now that we've seen it? What's the next steps for us?
Fantastic question. So now that we have an image of one black hole, what scientists want to do is try to use the same techniques to image other areas of our fantastic universe. And there's some theories that we want to test on how objects move around large objects, what happens when a black hole spins. It's complicated enough as it is to think of a black hole as just this void in space.
I had no idea it spun.
But black holes also spin, and their spinning causes different effects in how things spin around them. And what happens to these jets of light and radio waves that come out through black holes? They're 4,000 light years long. Black holes chew up stars and they spit out these giant streams of light. What happens to them? Where do they come from? And what happens to information? So that was Stephen Hawking's. That one of his big research was that black holes leak information. So how do we know? How can we look at that and know what goes inside a black hole? So we are on the ground floor of a whole new way of thinking about science on the planet. This is super exciting for us as a species. This is one of our biggest achievements to date.
Wow.
I feel like when we're talking about this, like, and I feel like I'm like a dog that's excited for like going outside. I understand that I'm excited, but do I know why I'm excited?
What are you going to do with the car when you catch it, Steve? What are you going to do with that black hole when you get there?
Like some of the stuff we're talking about is so beyond my comprehension that I'm glad we have somebody like you to talk about it.
Yeah.
Happy to be here.
Yeah.
So when I was in grad school in physics, one of the things that I would ask people is, what are 3 things you'd like us as a species to achieve, during our finite time here on the planet, right, individually? And for a lot of people, being able to see a black hole was one of their bucket list things. So a lot of people out there, space fills us with wonder and dread.
Oh, for sure.
And it's that combination of those existential feelings, because you're 55 billion light years away, million light years away.
Yeah.
The mind boggles.
Yeah.
It's difficult to think of these things. It fills you with a sense of wonder and hope. Humanity throughout history man has looked up in the sky and said, what's that? I want to be there. So what you're experiencing is something that our ancestors and everyone who's ever walked this earth has experienced. It's the wonder and joy of space.
Well, unfortunately, we only have so much time to talk about the wonder and joy. I'm lost into it. But thank you so much for being on the show, Abhi. We'll get you back for some more space stuff when more tremendous discoveries are made. Stay with us after the break for something more earthly here on Talk Nerdy.